Seeking English, S.A.T. Workbook, page 420, problem 3, no calculator. This is what we call the tennis ball problem. Now, if you remember the stapler problem, I mentioned that it is superficially similar to the tennis ball problem, and you need to study these probably next to each other at some point to get the full value out of them. So it says no calculator. You really shouldn't need a calculator for this. Again, it's reading histograms. It says tennis ball production, and vertical axis says canisters of tennis balls in millions. Okay, even if it were individual tennis balls, the answer to this thing would be the same. It shows, so that's 0 up to 40 million, and it shows years 1996 through 2003. Okay, in tennis ball production. It says, the bar graph above shows the number of tennis balls produced in the United Kingdom for the years 1996 through 2003. For which of the following 2-year periods was the average arithmetic mean, average meaning arithmetic mean in this case, it's parentheses, tennis ball production closest to the tennis ball production in 1996? Okay, so you look at your base year as your first year. Maybe that's convenient. It's a little bit over 20. Could be 22, 23. It's debatable. We can't be absolutely certain, but the number itself doesn't matter. We're looking at the comparative heights of these bars. Okay. Options are for 2-year periods. 1996 through 1997 is a 2-year period. 97 through 98 is a 2-year period. 99 through 2000 is a 2-year period. 2000 through 2001 is a 2-year period, and then there's some extra data on the graph that is not going to be at all useful. Okay, so just mentally mark out here's 2002, 2003. Not useful. Okay, it doesn't affect the other data. Okay, so you're looking for average arithmetic mean. Now, you remember in the stapler problem, I suggested that the first thing you should try to do is figure out a collection of years that included the base year. But that was a sample of 3 years. They were looking for an arithmetic mean of 3 years, meaning you could have that year, your reference year, and you could have a year where there's more and a year where there's less, and it would balance out. And that is more or less what happened in the stapler problem. That doesn't happen in this case, because if you have a base year and you have only one other year, it's going to be larger or smaller than that, and so it's going to pull the average away from that thing. So, seeming to contradict what I said in the stapler problem, I want you to not first consider a pair of years that includes the base year, because the base year and that other year are going to produce an average that is probably going to be further away. Think about it a little bit. Is what I'm describing absolutely always true? Well, it doesn't need to be absolutely always true. I'm telling you what to look for first. Okay? So 96 through 97 is a bad candidate for a pair of years. For that reason, it includes the base year and a year that's very different. Okay, so if they were the same, that would be great. They're not. 97 through 98, both years are lower than 96. That makes that pair of years even worse, because the mean between those years is pulled even further away from the base year. Okay. 98 through 99, again, 98 through 99 isn't one of the choices. Cut. No, we're going to continue. 99 through 2000 is on the list. Okay, and in that case, you have one score that is lower and one score that is higher. So that is potentially a good answer. Okay, if you're looking at a pair of years that doesn't include your base year and it's only 2 years, what you want is one that's higher and one that's lower, so they balance out. Okay, 2000 through 2001, both are higher, and so for the opposite reason, that would be a bad pair of years. The average between those 2 years is going to be pulled away from the base year. Okay, but if your base year is in between the 2 years in your sample, then the average is going to be somewhere in between those 2 years. It could be close to your reference year or your base year. I hope I've explained this well. This is more of an eyeball problem than a math problem. And if you miss something, I hope it would be just what I did. That pair of years isn't in there, etc. If you just learn to use your eyes well, it will serve you in problems like this. And can you learn to do this just by doing it more? Yes, you can. If it for some people it never becomes easy, but it can become effective for people to whom it is not immediately effective, and it can become extremely efficient to people to whom it is already effective. And I want you all to get those points, all of you. So if you want or need extra help with graph problems like this, tell me again. I hope I've linked in the description back to the stapler problem. I if you check the stapler problem, eventually it should have a link to this problem. But when I loaded the stapler problem, my video for this problem didn't exist. So figure it out.